myself Ashish, and I'm a product of BHU only. I have done my masters from this place. In 2008, I passed. Then I joined PhD at National Institute of Medical Statistics, as ma'am has told. So, statistics tools in health research is the topic in which we will be having some introduction on that things. Statistics, as it is a branch of your mathematics, okay, and we will see that why we are studying that things. Okay. So this is the sequence of presentation which we will be talking about. The statistics defined, then we will be having some descriptive statistics, then correlation, hypothesis testing, the regression analysis, vector analysis, and meta-analysis. Actually, the statistics is a vast ocean, and sir is very well knowing it that it is very difficult to cover the entire statistical tools. Okay, so but I am covering few tools which are really very important for our perspective. Okay, now we would be finding a lot of definition is there of statistics. Okay, so I would be trying to tell you the things from a layman perspective. Okay, so statistics, as I have told you, that is evolved from mathematics. So the first question which arises is that what is the need of mathematics in medical sciences? Okay. So what is the need of mathematics in medical sciences? Mathematics is basically dealing with certainty. 2 plus 2 is always 4. Okay. But if you are having a pregnancy outcome, it is not a certain event. Okay. If you are having a toss of a coin, it's not a certain event. Okay. And we all are interested in uncertainty, especially in medical sciences. We are very much living in the world where we are having a lot of dilemma. So we want to know a scientific way with which we can evaluate, or rather we can reduce the amount of uncertainty. So statistics is what? Statistics is nothing but it's a science with the help of which we can deal with uncertainty. Okay. So in books we have the definition. Statistics is defined as a science and practice of developing human knowledge through the use of empirical data. Okay. Now in the books we are finding this definition. So why we are finding this definition? Why? Because you must be knowing that the language of science is data. Data is the language of science. Okay. Often you must have heard in Hindi movies, the judiciary is saying that क्या सबूत है कि ये गुनाहगार है, या सबूतों के अभाव में इन्हें बरी किया जाता है. Okay, a company is claiming that my product, my drug is superior than the existing one. He is giving a p-value for that. That means he is finding out some probability value which depends on the data. So in scientific world, theoretical or theory is getting approved only when you are having some sufficient number for that things. Okay. So that's why in definitions, bookish definitions, you will always find that it is a science of data collection, compiling, and all that things. But at the core of heart, what is the basis of statistics is that it is a science which is giving you an idea about uncertainty. For example, we have in SI units we have meters for measuring length, for measuring weight we have kg. Similarly, in probability or in statistics, to measure the uncertainty, we have a tool which we are calling it as probability P. Okay. Now, our aim is to talk about, we want to talk about the population. Okay. We want to talk about the population. We don't want to talk about the sample. Okay. So, but you know that it is very difficult to study the entire population. So, what we are doing, we are choosing a small sample, and we, based on that sample, we are making some inferences. Okay, so the very first thing which we have written here is statistics defined. Okay, so the characteristics, no one is interested in a raw data set. If I say that the census has collected so variables, 110 variables, and this time we are having data of 3 GP. So you would, when the word census hit your mind, the first thing which came from the first question which you would be asking you is, sir, just tell me that whether our population is increasing or decreasing. We don't want the entire information. Okay, if there is a study on so your NFHS, you will be asking us that, sir, tell us what is the total fertility rate. So we all are interested in the nature or characteristics of the data. In the raw data, we are not interested. Yeah. Unfortunately, the raw data is only making the statistics or the characteristics of the data. So data, while statistics we are studying in different domains, be it medical science, be it biology, it's not that the science is very important. Of course, science is important, but one nature of the data is there because of which it is becoming popular in every field. What is the nature of that data is that in the form of statistics, we have it in a form of a central limit theorem. Okay, so what exactly the central limit theorem will be saying is that if you keep on accumulating the data has a tendency to move towards the central point. Okay, and that central point we are interested in studying. Okay, so that's why the NMC, previously MCI, has made it mandatory that we should have a sound medical records system. To know the exact nature of a disease, we need to have data recording. It's very important. Okay. So now the statistics which we are covering the sample, based on that we are making the inference about the population. So in research, two things are very important from statistics perspective. First is that the sample which you are choosing, it should be a representative sample. Okay, so how we are choosing, it is important. That is, the sampling technique is very important. And second one is that how much you are choosing, that is the sample size is very important. Okay, so there are two methods of choosing it. One is based on the theory of probability. Probability, you already know that how, if I ask you what is the probability of getting a 6 in a dice throw, what we will be getting? 1 by 6. Yeah. If I will be asking you what is the probability that in a particular pregnancy outcome we will be having a female child, it's 1 by 2. But if I say that, tell me what is the probability that the fan above your head will fall down, you cannot say. Yeah. But let me tell you, it's not zero. Yeah. I'm not trying to make the fear, but the thing is that at the back of your mind, you are using a formula which is favorable divided by total. And it is satisfying certain axioms which you are following. The first one is the axiom is that it should be even should be equally likely. Okay, that means in a toss of a coin, if I say head and tail are equally probable, in a pregnancy outcome, male female are equally probable. In a dice throw, 1 to 6 outcome are all equally probable. Okay, but this is not an equally probable event. Second axiom is that it should be mutually exclusive. Okay, mutually exclusive, what it means is that if you are having a female outcome in a particular trial, in the next one, the possibility of having the male child in that particular outcome will be ruled out. Okay, you cannot have a male child in that occurrence. Okay, so it should be mutually exclusive, and it should be, third one is it should be independent. Independent means that occurrence of first dice throw has nothing to do with the second one. Okay, and the last one is that it should be exhaustive. Exhaustive means that you should know all the possible events. So when we are doing a research, we should try to have a sample selection which should be equally likely and try to satisfy the probability axioms. So if you are trying to satisfy all the axioms, 4 axioms which we have cited, then we would be saying that the method which you have used is probability sampling method. Of course, there are different types of within the probability we have, SRS, stratified and all that. But In short, this probability sampling is following all these four exams. So if you are doing that, that means your selection is probable. And if your selection is probable, then you can generalize it. Okay. If I say that in this class I would be choosing one individual and I would be providing him the ticket for the malls with the fooding and all that things. So how the selection I should do that everyone should feel that they are not cheated. They have got the equal opportunity. So what I should do? I should choose someone which is very close to me, or I should choose someone which is very far from me. And if I am doing all these things, you will say that my selection is a biased one. So what I can do is that I can make a thing, I can make an arrangement such that each and everyone is having equal chance. So what I can do is that I can make the each unit equally probable. So I am going to do it. I can make a chit. I can arrange you in a roll number and I can assign you a chit. And roll number 1, 2 like that. And identical chits I can have, and using lottery method, you can select randomly one. And in this, if you are having 50 participants are there, each one is having equal probability 1 by 50. So if you are having a selection like that, then we would be saying that it's a fair selection and your results can be generalized. That's why we are having a lot of emphasis on the selection process, which people are referring it that it should be random. So by making it random, what we mean is that we are trying to make each and every unit equally probable. Okay. Now, so once you have got the sample, which is probable one, then what we would be doing is that firstly we would be trying to explore the data. Your objective might be a very deep one. You want to have the relationship between, say, MI and a type of a lifestyle habit, like that. But at first, what we should do is that we should try to explore the data, what the data is telling us. Okay, that means we should try to find out the raw characteristics of the data. By saying the raw characteristics of the data, I mean you should find out what is the average value of your data set, what is the average value of data set, and what is the average value of dispersion in your data set. That means how much the values are deviating from the central value. Okay. So often when we talk a word or we coin a word average. So people are calculating average. How you are calculating average? Total number of observations divided by number of observations. So if we have to have an average marks obtained, so what you will do, you will add all the marks in the subject and divide by the number of subjects. Okay. But suppose if I am giving you a figure where we are having 5 data set and I am telling you that after a critical surgery, the years of survivals are given to you. The first patient survived 5 years, the second patient survived 4 years, then the third patient survived 6 years, then the fourth one again survived 5 years, and the sixth patient which we are getting, the last patient which we are getting, has survived for 25 years. Okay, and if I am telling you that, tell me what is the average duration of survival. So what will be the average duration of survival? Should we add all the numbers and divide it by the number of observations? Okay. So if you are doing so, then what you will be getting? You will be getting a value which is around 8, 9. Okay, okay, and then you can match your finding. Average means, जिसे हिंदी में बोलते हैं औसतन वो व्यवहार होना चाहिए, एक वैल्यू जो सारे वैल्यू का रिप्रेजेंटेटिव होना चाहिए, and you are getting a value which is 9, and you can match. First value is 4, then 5, then 6, then 5, then we have 25. None of the values are matching. So it's a very, very important concept that before making a descriptive statistics or before exploring your data set, you should look at the nature of the data. What is the nature of the data? If the data nature is in your data set you are having extreme values, you should look at the measure which is more reliable for average. So if you are having very extreme value, instead of going for arithmetic mean, you should go for median value. Similarly, if your data set is having a value which is most occurring values, frequently occurring observations, ECG graph we have seen, we are having multiple modes. Okay, in that case, instead of having mean or median, we can go for a mode which is a better representation of the data set. Okay. Once we have the measures of central tendency, which we are calling it as a mean median mode, then we can have the measures of dispersion. Measures of dispersion means what? It says that on an average, how much is the deviation of each and every values from the central value. Okay, it's very, very important. Okay. Okay. So if you are having less deviation in your data set, then you can be more confident about the central characteristics. There was a match, cricket match, and we have seen that it is a test match, I think, between India and Australia. And the total score scored by Indian player Sachin Tendulkar was matching with the Australian player, Steve Jobs, Ponting, sorry, and they have scored equal runs. But at the end of the day, the award was given to the Australian player. Why? Because our player has scored very high in the first and in the last 5-day series. But at the rest of the 3 days, he has not played good. Whereas the Australian player was very consistent over a period of time. Okay, so measures of central tendency should always be supported by measures of deviations. How much each and every values are deviating from the central value. Okay, the closer or the compact the values you are getting with the central value, the more reliable your data sets are. So we have few measures of dispersion, which we are calling it in the scientific term. We have mean deviation, we have range. Range is basically not a scientific measure of dispersion, but it is just you can have the overall picture, what is the highest value and what is the lowest value, range. Okay, and if these two values are not the representative of your data set, you would be getting a unreliable measure of dispersion. The scientific one is standard deviation. Okay, sometimes what happens, sometimes the nature of the data is such that you are measuring, say, BMI. One data set is measuring BMI and another data set is measuring, say, bone density. And you know that both the unit of measurement is very important. Both are measured on a different unit of measurement. In that case, to have the quality of the data set, which data set is more reliable, we generally use another measure of deviation, which we are calling it as coefficient of variation. Okay. So coefficient of variation में हम क्या करते हैं? We are finding out the mean of the first data, and we are seeing that with respect to the first data, how much each and every values are varying in that data set. Similarly for the second one. Okay. Now, once you got the idea about the descriptive statistics, or you got the idea about the how your data is behaving, exploring, then your interest might be that you can have looking at the tabular presentation and the graphical presentation. Scatter plot आपने बनाया, and you find that there is association with BMI and say disease with that. So what you can have, you can go in deep and you can have some correlation studies. Okay. Okay, so correlation, the word correlation is used in day-to-day life to denote some form of association. Okay, so basically data is of two types. So one is your qualitative data and second one is your quantitative data. If I say quantitative data, it means that we have definite idea about magnitude of the data as well as the direction. That means if I say BMI 18, 20, 25, that means I know the direction 18, 20 and 25. And I know the magnitude also, what is the difference between the two. But if the data is of intelligence or disease severity, you have categorized it as mild, moderate, severe. You know the direction, but you may not know the magnitude. For some physician, the categorization, one individual which is in moderate category can be in severe category for him. So here you are having the direction, but might not have the exact idea about the magnitude. So in correlation, we are trying to establish the relationship between two numerical values. And if it is not numbers, then we find the term association. Okay. If the association is strong, then an attempt may be made mathematically to develop a predictive relationship between two variables, so that given the value of one, the other may be predicted from it. Okay. So if you get to know that the correlation is very strong, you are getting a value of correlation which is very high, then you may develop a mathematical model with the help of which you will try to find out that if we are changing one variable, what would be the change in the other variable. For example, if I say we are having two variables, say age of gestation and baby weight, and we find that the scatter plot is positive and the correlation is coming out to be very high, then we can develop some mathematical model which might predict that if the age of gestation is changing, yeah, how much effect it is having on the baby weight. Okay, so this type of mathematical relationship can be established if the correlation is very strong. Okay, so before having the correlation values, we can have the descriptive measure for correlation. Here we are having three graphs. Okay, so first one is having a positive relationship between the predictor variable, response variable, and your independent variables. Second one is having an inverse relationship. So whenever we are getting an upward trend or a downward trend, it is giving us an idea that some form of relationship is existing. Okay, and if somehow you are getting a circular presentation or a parallel presentation between the lines, it is an idea. It is giving you an idea that the correlation might be very weak. Okay, sometimes what happens, you might get the third one. Okay, you might get a relationship which is of this nature, parabola nature. Okay, so it is also giving you an indication that the correlation is existing. But what is different here is that the relationship is not linear. Okay, it's having a second order relationship. Okay, it's having a second order relationship. So you can see that the relationship is not linear in nature, but it can be of second order. Quadratic relationship is there. Okay, so but the relationship can be very, very strong. Okay. So correlation allows an examination of relationship between variables. Is there a relationship between these variables? Are they positive or negative? We have a range from +1 to -1. Generally, the values lie in between. Okay. Correlation coefficient interpretation. How much the value of correlation you will be saying is high? It generally depends on your objective. What is your objective? If you are having measurement of physical quantities which are physical in nature, physics one, physical experiment related to physics, it should have a very, very high correlation values. But if you are dealing with a science such as medical science where we are having a lot of uncertainty, there we can have a value of 0.7 or more, maybe said that there is a strong correlation. 0.5 may be a good correlation, a value of 0.3 to 5 may have a moderate correlation. Again, it will depend on your objective, what type of objective you are framing. Okay. It's important. Correlation is not causation. It's very, very important. Okay. Often you will find that people are stating that we have got a correlation between two variables and we get to know that the correlation is very high. We are having 70% correlation. And they state that the p-value is also very, very significant. Okay. But then also it is not very sure that the correlation is very true. Why? Let me give you an example. For example, we are having a study where you are having, say, cohort study you are having, and you have what you are studying the relationship between MI and smoking. Okay, MI and smoking, or MI and say alcohol you are studying, and you find that there is a very good correlation, very high correlation between MI and smoking. You are getting a very high odds ratio, p-value is also significant over there. Okay, so from that, looking at that value, you said that alcoholism is leading to your MI. Okay, later on, some researcher explored in more detail the study, and he find that the individuals who were alcoholic were chronic smokers. Okay, and it is not the alcohol which is causing the odds ratio to be high. It is the smoking which is giving rise to the OR values. So if someone is doing a stratified analysis, taking the confounding effect of smoking out, he will not get a correlation, and probably he will not get a p-value which is very significant high. So whenever we are dealing with correlation, it is just telling you that there exists a relationship. That relationship should be explored in the light of confounding variables and in the light of interaction variables. Whether you should look at that things, whether in that relationship there should not be any confounding, there should not be any interaction, okay, between the response and the independent variables. So if you are getting that there is the relationship is very strong and confounding effect and interaction effect, you are somehow you are able to control it, then we can have a more deep model where we can develop a mathematical model to deal with the things. Okay, so there we can have, okay, coming on the correlations types. Okay, so depending on our objective, we have generally we are having 6 different types of correlation. Pearson correlation coefficient generally we use when we are having two variables x and y, and which is quantitative in nature, and they are following normal distribution. Okay, they are following normal distribution. Often you will come around the word normal distribution in medical sciences. If it is following normal distribution, we have a different approach. If it is not following a normal distribution, we are having a different approach. So what exactly this normal means? Normal generally means that it's when we are plotting a scatter plot or you're having a frequency distribution. Generally, in any type of plotting, the outcome variable or response we are having on the y-axis, and the independent variable we generally put on the x-axis. And if you are for a continuous variable, if you are plotting a histogram, and by joining the midpoints of a histogram, if you are able to see that a bell-shaped curve you are getting, it is giving you an idea that your data set might be following a normal distribution. So normal distribution is very popular. Why? Because it has a wide applicability, and generally lot of medical data are following normal distribution. But there are many data I have seen which are quite good in number also, but then also it is not following normal distribution. So before making any parametric or non-parametric, doing any testing of hypothesis, one should be very sure that it should meet the assumptions. Okay, so if the x and y variables are normally distributed, then we can have Pearson correlation coefficient. If x and y variables both are quantitative variables, but unfortunately you are having less numbers and it is not following normal distribution, then in that case what we can do, we can use, instead of using the absolute value, we are using the rank of the values, and in that case we can use we can calculate the Pearson only, but instead of using the absolute value, we are using the rank values, and then we are calculating the correlation between the values, and we are calling it as Spearman rank correlation. Often what will happen, there might be observations which are having similar ranks. So if you are having a lot of tied observations, then in that case we can have Kendall's tau measurement. Okay. Now, sometimes what happens, our outcome variable might be continuous, for example BMI, whereas the second variable might be discrete in nature or might be dichotomous in nature, for example disease, yes, no, like that. And if you have to find out the correlation between the things, we are using point biserial correlation coefficient. If the categorization of the variables is not natural, that means if you are categorizing, if the dichotomous categorization is natural in nature, for example gender, male, female, but if you are categorizing based on the BMI, if you are saying that BMI if 25 and above, we would be putting it as 1, 25 and below, we would be putting it as 0. It's not a natural classification, you are categorizing yourself. In that case, we, instead of using the point biserial, we are using biserial correlation coefficient to measure the relationship between the variables. Phi coefficients generally we use when x and y both variables are dichotomous in nature. Okay, both are having categorical values. Then in that case, we can use Phi coefficients. Once you got that the correlation is strong, okay, then often we are interested to find out whether there is agreement in this measurement with respect to the agreement in other measurement or not. Okay, so if the variables x and y are continuous in nature, then to see the agreement between two variables which are continuous in nature, we are using a plot which we are calling it as a Bland-Delterman plot to see the agreement is having a good agreement exists between the variables. Okay, and if you are having the agreement, you are measuring the agreement where the variable is categorical in nature. Okay? For example, you are having disease category. A pathologist is there. He has categorized it as in grade 1, grade 2, grade 3. The same set of sample, if another independent pathologist is observing, he has also categorized it as grade 1, 2, and 3. Now you want to find out whether the two categorization has a good agreement or not. So if the variable nature is not x and y are not continuous in nature, then instead of using Bland-Delterman plot, generally we are using kappa statistics to measure the agreement between the two pathologists in this case. Okay, so once you get the descriptive statistics, once you get the relationship and you have checked the agreement, now it's time to see whether the correlation is really real in nature or not. So we would be performing a testing of hypothesis for that thing. Okay. So testing of hypothesis, as you know, that is made up of two words, testing and hypothesis. So testing means we are verifying the things, and hypothesis is basically assertive statement about a random phenomena. By saying random phenomena, I mean that the outcome is not certain. Okay. So basically, it is of hypothesis is of two nature. One is the null hypothesis, and the second one is your alternative hypothesis. So what is null hypothesis? As the name says, which conveys no difference meaning. Okay. If I say that the male IQ is as good as that of female IQ, this statement is null in nature because it is conveying no difference meaning. But if I say that the average IQ for a female is more compared to a male, then I'm choosing one side. Okay, it's not a null statement. So in that case, it is a alternative hypothesis. So in testing a hypothesis, generally we perform certain steps, certain scientific steps to come upon a decision whether we should go with the null hypothesis or we should go with the alternative hypothesis. Okay, whether you are performing it for a correlation, whether you are performing it for a mean testing, whether for proportion testing or association, the only goal is to decide whether we should stay with H0 or we should choose HA, alternative hypothesis. This is an example. Considered a reputed nephrologist who asserts that the GFR rate in chronic renal failure cases on an average is nearly half of the normal rate. You are not convinced and conducted an investigation of 30 consecutive CRF patients and find that the average GFR is 42% of the normal. In view of sampling fluctuation, can the value of 42% in these 30 patients can be considered to go against the assertion drawn by the specialist? What do you feel? The specialist says that it is 50%. Okay, you are not convinced and you have conducted an independent survey and you find that the rate is not 50, it is 42. So should, based on the value which we have got 42, should we say that the assertion drawn by the specialist is not right? Let's make it 300 then will you say that the specialist is not right in his assertion? We have to test it. We have to test whether the 8% deviation which we are getting is enough to make a conclusion that the inference drawn by the specialist is not correct. Okay, so these type of experiment are random in nature. You don't know. So when the experiment is random in nature, we generally commit two types of error. Okay, so experiment random है, outcome आपको मालूम नहीं, तो आप क्या करेंगे? आप दो तरह के error करेंगे. क्या कर सकते हैं आप you might reject something which is true. आप सत्य को नकार सकते हैं. Second क्या है? आप कोई गलत चीज को अपना सकते हैं. Okay, so if you are rejecting the truth, we are committing an error which is denoted by type 1 error, and we are in symbol we write it as alpha. So alpha level or significance level is a value that is determined by the researcher in order to reject or retain null hypothesis. It is predetermined value, not calculated. We generally fix the type 1 error which we are willing to allow in our study. Okay, so if you are willing to allow a very small error, 1%, okay, you want a very high quality testing, okay, then what you have to do is that you should be covering more number of individuals. You will be getting less standard error, but it will require more time and more money. Okay, ideally, in general, we allow an error of 5%. Okay, so we are allowing an error of 5%. That means our level of significance at which we are testing is 1 minus alpha, that is 95%. Okay. Okay. Type 1 error, example here we have seen that in a trial, new drug X, the null hypothesis might be that the new drug is now no better than the current drug Y. So this null hypothesis, if you are rejecting, you are having a type 1 error. Okay. Second one is type 2 error, which we are calling it as beta. So type 1 error is what? Type 1 error is the probability of rejecting the null hypothesis when it is true. So अगर आप सत्य को नकार रहे हैं तो आप टाइप 1 एरर कमिट कर रहे हैं, ठीक है, और आप गलत चीज को अगर अपना रहे हैं तो यू आर कमिटिंग अ टाइप 2 एरर, ठीक है। सत्य ये है कि एक जुडिशरी का ट्रायल हो रहा है, कोर्ट का ट्रायल हो रहा है, सत्य ये है कि जो इंडिविजुअल है वो इनोसेंट है, बट यू हैव रिजेक्टेड द ट्रुथ एंड यू हैव पनिश्ड हिम, यू हैव डन अ एरर, you have committed a error. So this is an error. Now एक second scenario है कि the individual which is there, which is tried, is a criminal, but you have accepted him as an innocent and you have released him. Which one is a more serious one? Second one or first one? First one. In judiciary, it is very clear cut that an innocent should never be punished. थोड़ा सा कंफ्यूजन है तो थोड़ा एक दूसरा एग्जांपल देखते हैं. अ ड्रग इज देयर व्हिच इज टॉक्सिक इन नेचर, टॉक्सिक इन नेचर, एंड यू हैव रिजेक्टेड द ट्रुथ द ड्रग इज टॉक्सिक एंड यू हैव गिवन द परमिशन टू मार्केट इट. ओके, second scenario is there, the drug is effective in nature but you have accepted it that it is not effective and you have not given him the permission to be market. तो आप क्या है, सस्ती दवा, अच्छी इफेक्टिव दवा आपने नहीं मार्केट होने दी, क्या होगा, नेक्स्ट टाइम वो फिर से अप्लाई करेगा और ड्रग माइट गेट अप्रूवल. जो क्रिमिनल नेचर का आदमी है वो फिर से क्राइम करेगा और वो पनिश हो जाएगा, लेकिन जो इनोसेंट है वो उसके लिए वो चीज़ रिवर्सिबल नहीं है. मॉर्टालिटी अगर हो गई उस ड्रग से तो वो रिवर्सिबल नहीं. तो वी जनरली फिक्स द टाइप 1 एरर इन आवर रिसर्च वेल इन एडवांस. सो करते क्या है टेस्टिंग ऑफ हाइपोथेसिस में, इस समरी में मैंने लिखा है. So in the process of hypothesis testing, the null hypothesis initially is assumed to be true. ठीक है, हम ये मानते हैं, इससे शुरुआत करते हैं. इसकी शुरुआत जो है स्टैटिस्टिक्स से नहीं हुई है टेस्टिंग ऑफ हाइपोथेसिस की, इसकी शुरुआत फिलॉसफी से हुई है. इन फिलॉसफी जब चीज़ों को अप्रूव करना था या डिसअप्रूव करना था तो वो क्या करते थे, पहले डेटा कलेक्शन हुआ करता था ना. आप देखते थे जितने फिजिक्स के जो पहले के लोग हुए हैं, एक्सपर्ट हुए हैं, तो सब जो है सबको फिलोसफर कहा जाता है. फिलोसफी के सिद्धांत को फॉलो किया जाता था. तो ये वहीं से स्टैटिस्टिक्स में इवैल्यूएट हुआ है थोड़ा और मॉडिफाई हो गए. तो पहले क्या किया जाता था, पहले सारी चीज़ों को बोला जाता था कि समान है, ड्रग ए भी उतनी अच्छी है, ड्रग बी भी उतनी अच्छी है. हम इस बिलीफ से चलते थे और फिर हम क्या करते थे, हम डेटा कलेक्शन करते थे. डेटा कलेक्शन हम लोगों ने किया. किस तरीके से डेटा कलेक्शन किया, जैसे पहले हम लोगों ने डिस्कस किया, इस तरीके से चूज किया कि वो प्रोबेबिलिटी सैम्पलिंग जो है एडिक्वेट है, मतलब राइट प्रोबेबिलिटी टेक्निक है और राइट अमाउंट में, ठीक है. फिर आपने चूज किया. सैंपल को चूज करने के बाद हम क्या करते थे, हम देखते हैं कि जो हमारा नल हाइपोथेसिस है उससे हमारा डेटा मैच कर रहा है क्या. अगर हमारा नल हाइपोथेसिस, जैसे हमने कहा कि बॉयज़ का IQ उतना ही है जितना गर्ल्स का IQ है, और हमने डेटा निकाला जब, तो डेटा में भी ऐसा आ रहा है कि प्रोबेबिलिटी बहुत हाई है, मेल्स आर हैविंग सेम IQ एज दैट ऑफ फीमेल्स. तो हमारे डेटा की मैचिंग नल से बहुत ज़्यादा हो रही है. दैट मीन्स वी आर गेटिंग अ हाई P वैल्यू, प्रोबेबिलिटी वैल्यू बहुत हाई आ रही है. ठीक है। तो प्रोबेबिलिटी बहुत वैल्यू बहुत हाई आ रही है, या इसका मतलब हमारा डेटा, आवर डेटा इज मैचिंग वेल विद द नल हाइपोथेसिस। देन इफ आवर डेटा मैचेस वेल विद द नल हाइपोथेसिस, सो वी आर नॉट रिजेक्टिंग द नल हाइपोथेसिस। तब हम कहेंगे कि मेल का आईक्यू और फीमेल का आईक्यू दोनों बराबर है। इस केस में, नेफ्रोलॉजिस्ट के केस में, अगर मैचिंग अच्छे से आएगी तो हम कहेंगे कि ये जो 8% का वेरिएशन है ये सैम्पलिंग के कारण हो रहा है। दूसरा सैंपल चूज करेंगे तो फिर वेरिएशन और कम हो जाएगा, हो सकता है तीसरे वाले में वही आने लगे। ठीक है। अगर ऐसा होता है कि मैचिंग बहुत ज़्यादा हो रही है, तब तो हम कहेंगे कि H0 के साथ जाना चाहिए। लेकिन अगर मैचिंग ऐसा नहीं हो रहा है, आपने तो सैंपल में किया और आपका जो ऑब्जर्वेशन आ रहा है और जो डेटा में ऑब्जर्व हो रहा है दोनों अलग अलग आ रहे हैं, मैचिंग नहीं हो रहा है, तब उस केस में हम कहेंगे कि नहीं, दोनों चीज़ें अलग अलग हैं। मेल्स का आईक्यू मैच नहीं कर रहा है फीमेल्स का आईक्यू, इसका मतलब देयर इज अ डिफरेंस बिटवीन द टू। ओके, तो इसी को हम स्टेप्स में भी देखेंगे कि स्टेप्स क्या हैं। ओके, ये देखें, ये है। तो किसी भी टेस्टिंग ऑफ हाइपोथेसिस में हम जनरली यही स्टेप्स फॉलो करते हैं, whether you are doing it for correlation, regression, prevalence, or whatever study you are doing. So at the heart, at the core, we are using this steps. So first is that you should state the problem. What is your problem? And based on your problem, you will be stating the H0 and HA clearly. Null hypothesis or alternative hypothesis को clearly state करना है। Alternative hypothesis दो तरह की हो सकती है, जैसे कि हम लोगों ने बोला कि मेल आईक्यू और फीमेल आईक्यू समान नहीं है, यानी हो सकता है कि ज़्यादा हो सकता है कम भी हो। लेकिन कभी कभी क्या होता है कि सिर्फ एक टेल में वैल्यू लेता है, जैसे कि हम बोले कि होमोजीनियस पॉपुलेशन है और हमने क्या किया, एक पॉपुलेशन को हम नॉर्मल फूड दे रहे हैं, दोनों को नॉर्मल फूड दे रहे हैं, लेकिन एक पॉपुलेशन में हम क्या कर रहे हैं, 1 घंटा वर्कआउट करवा रहे हैं और हमारा एम है कि वेट लॉस हो रहा है या नहीं हो रहा है। तो नल क्या होगा कि पहले जितना वेट था बाद में भी उतना ही वेट था। ऑल्टरनेटिव क्या होगा, एक्सरसाइज करने से ऑन एन एवरेज वेट बढ़ेगा क्या, नहीं बढ़ेगा, क्या होगा, ऑन एन एवरेज इट विल बी रिड्यूस। तो यहाँ पे टू टेल्ड नहीं है। तो ऑल्टरनेटिव हाइपोथेसिस जब हम फ्रेम करेंगे, तो इफ यू आर वेरी श्योर अबाउट द नेचर ऑफ द प्रॉब्लम, यू कैन फ्रेम अ वन टेल ऑल्सो। इन जनरल इफ यू आर नॉट हैविंग द आइडिया, यू गो फॉर अ टू टेल हाइपोथेसिस। तो पहला वाला हो जाएगा, वी विल बी स्टेटिंग द H0 एंड HA क्लियरली। Then identify the test statistics. Okay, one tail or two tail, and identify the distribution. Generally अगर हम मीन के बारे में बात करना चाह रहे हैं तो मीन के लिए हम अलग डिस्ट्रीब्यूशन यूज करेंगे। अगर हम कोरिलेशन के बारे में बात करना चाह रहे हैं तो हम अलग डिस्ट्रीब्यूशन यूज करेंगे। ठीक है। And depending on the type of risk you are willing to take, specify the level of significance. If you are having lot of money, lot of manpower, you can have a very low type 1 error है। आप 1% एरर ही बस अलाउ करिए, लेवल ऑफ सिग्निफिकेंस बहुत हाई रखिए, आपका सैंपल साइज ज़्यादा आएगा लेकिन यू कैन कवर इट। और फोर्थ स्टेप में क्या करेंगे, ये जनरल फॉर्मूला लिखा है मैंने, ये थोड़ा सा मॉडिफाई होता है अगर आप स्पेसिफिक टेस्ट यूज करते हैं। वो क्या है, ऑब्जर्व्ड वैल्यूज माइनस एक्सपेक्टेड वैल्यू डिवाइडेड बाय स्टैंडर्ड वैल्यू। ऑब्जर्व्ड वैल्यू मतलब आपके डेटा में क्या वैल्यू आ रही है, ठीक है, एवरेज आईक्यू मेल का कितना आ रहा है, और एक्सपेक्टेड वैल्यू कितना एक्सपेक्टेड वैल्यू हम एक्सपेक्ट करेंगे कि मेल पॉपुलेशन में आए। एक्सपेक्टेड वैल्यू जनरली हम कैसे निकालते हैं, हम इसको फ्रीक्वेंसी डिस्ट्रीब्यूशन से निकालते हैं, है ना। जनरली हम जो डिस्ट्रीब्यूशन यूज करेंगे हम उससे निकालेंगे। एक एग्जांपल हम लोग देखेंगे chi स्क्वायर का, तो एक्सपेक्टेड कैसे निकालते हैं। और ये दोनों को माइनस करने के बाद हम स्टैंडर्ड एरर से डिवाइड कर रहे हैं। स्टैंडर्ड एरर से क्यों डिवाइड कर रहे हैं, स्टैंडर्ड एरर का कंसेप्ट स्टैंडर्ड डेविएशन से थोड़ा अलग है। स्टैंडर्ड डेविएशन में जैसे कि हम बात कर रहे थे, स्टैंडर्ड डेविएशन बताता है कि हर एक वैल्यू सैंपल मीन से कितनी कोरिलेटेड है। स्टैंडर्ड एरर क्या बताता है, स्टैंडर्ड एरर ये बताता है कि आपका जो सैंपल है वो पॉपुलेशन का कितना रिप्रेजेंटेटिव है। इन्होंने एक सैंपल चूज किया, आपने एक सैंपल चूज किया, इनके सैंपल में स्टैंडर्ड एरर आपके से कम आ रहा है, इसका मतलब इनका जो सैंपल है वो पॉपुलेशन का रिप्रेजेंटेटिव है, ज्यादा रिप्रेजेंटेटिव है। ऑल्दो ही माइट गेट सर्टेन वेरिएबल्स फॉर विच ही माइट बी हैविंग हाई स्टैंडर्ड डेविएशन वैल्यूज। तो स्टैंडर्ड एरर इज अ मेजर ऑफ सैंपल वेरिएबिलिटी विद रिस्पेक्ट टू पॉपुलेशन, whereas standard deviation is a measure of sample mean with the respective values। ठीक है, स्टैंडर्ड एरर और स्टैंडर्ड डेविएशन का कंसेप्ट क्लियर है। क्लियर है? आई होप इट इज क्लियर। ठीक है, तो अगर हम जैसे ऐसे बात करें, हमको मेडिकल साइंसेस के लड़कों का रिप्रेजेंटेशन चाहिए, तो हम क्या करेंगे, हम आईएमएस से सैंपल चूज करेंगे। ठीक है, तो हमको स्टैंडर्ड एरर कम मिलेगा। ठीक है, लेकिन अगर हमने एक सैंपल चूज कर लिया साइंस फैकल्टी से, तो वो क्या है, सैंपल रिप्रेजेंटेटिव नहीं है, वहां पे स्टैंडर्ड एरर ज्यादा मिलेगा कंपेयर टू दिस वन। ऐसा हो सकता है कि आपके सैंपल्स को जो हमने चूज किया, पहला वाला लड़का के नंबर बहुत अच्छे आ रहे हैं, दूसरे वाले के कम आ रहे हैं, तो स्टैंडर्ड डिवीजन ज्यादा हो सकता है, दैट इज अ डिफरेंट थिंग। बट सैंपल एरर का मतलब हो रहा है कि पॉपुलेशन, हमारी पॉपुलेशन क्या है, आईएमएस, आईएमएस का रिप्रेजेंटेटिव कौन होगा, यही का सैंपल होगा। ठीक है, और स्टैंडर्ड जब हम स्टैंडर्ड डेविएशन की बात करेंगे, स्टैंडर्ड डेविएशन की तब हम बात करेंगे जब होमोजीनियस है कि नहीं आपका सैंपल। ऐसा तो नहीं है आपने ऐसे बच्चों को ले लिया जिनकी अटेंडेंस बहुत कम थी, या ऐसे बच्चों को चूज कर लिया जो कि बहुत ओवरऑल क्लास में बहुत एकेडमिकली बहुत अच्छा कर रहे थे। ठीक है, तो वो जनरल पॉपुलेशन का रिप्रेजेंटेटिव नहीं होगा। ठीक है, तो हम क्योंकि हम पॉपुलेशन की बात कर रहे हैं, इसलिए हम सैंपल डेविएशन का मेजर यूज कर रहे हैं, विच इज स्टैंडर्ड एरर। ठीक है, नाउ बेस्ड ऑन दिस step 4 we are calculating the type 1 error. If this calculated type 1 error is more than the tabulated one, इसका मतलब tabulated one इसका मतलब जो हमारा डिस्ट्रीब्यूशन से निकलेगा, कंप्यूटर हमारा p वैल्यू जो बताता है, तो अगर p वैल्यू बहुत हाई आने लगी तो हम कहेंगे डेटा बहुत मैच कर रहा है नल से, तो हम कहेंगे नल हाइपोथेसिस रिजेक्ट नहीं होगी। लेकिन अगर वैल्यू लो आने लगी बहुत, p वैल्यू यू आर गेटिंग अ वेरी लो p वैल्यू, अगर आपने टाइप 1 एरर 5% ही अलाउ किया है और यू आर गेटिंग अ वैल्यू लेस देन 0.05, इसका मतलब योर डेटा इज नॉट मैचिंग विद द नल, यू शुड गो विद द अल्टरनेटिव हाइपोथेसिस एट अ गिवन लेवल ऑफ सिग्निफिकेंस। Okay, so this is an example where our objective is to have the testing of hypothesis, and here with respect to gender we are having voting preferences. So this is just example, nothing to do with anything. And if you want to find it out, the association of gender with respect to choice of the political party. Okay, so हमारा H naught क्या होगा? There is no association of gender with respect to the political choice. Alternative क्या होगा कि there exists some preference. There is some preference, and this is the first step which we will be doing. ठीक है, H naught और H हमने फ्रेम कर लिया। अब हम आ जाएंगे हमारे सेकंड स्टेप में, जिसमें हम डिसाइड करेंगे कि टाइप 1 एरर हमको कितना रखना है हमारे स्टडी में। तो बेस्ड ऑन द मैन पावर एंड फंड यू आर हैविंग, ठीक है, इफ यू आर हैविंग अ लॉट ऑफ फंड यू कैन रिड्यूस द टाइप 1 एरर, और इन जनरल वी जनरली अलाउ 5% एरर। ठीक है, तो हम अल्फा हमने 5% रख लिया, तो ऑटोमेटिकली लेवल ऑफ सिग्निफिकेंस 1 माइनस अल्फा 95% हो गया ना। इन द फोर्थ स्टेप we would be having we will be calculating the type 1 error, actual type 1 error in the data set. तो इसमें क्या हमने फॉर्मूला बताया था, ऑब्जर्व्ड वैल्यू माइनस एक्सपेक्टेड वैल्यू डिवाइडेड बाय स्टैंडर्ड एरर। ऑब्जर्व्ड वैल्यू ये जो सारी वैल्यूज दिख रही हैं, ये सारी वैल्यूज जो दिख रही हैं, 200 250 150 350 50, ये सारी ऑब्जर्व्ड वैल्यूज हैं। अब इनके लिए 200 ऑब्जर्व्ड है, इसके लिए हमको क्या एक्सपेक्टेड वैल्यू निकालनी है, एक्सपेक्टेड वैल्यू निकालनी है, तो हर एक के लिए अलग अलग है। जैसे इसमें हम एसोसिएशन निकालना चाह रहे हैं जेंडर के साथ में, एक्सपेक्टेड वैल्यू इसके लिए अगर हमको निकालना है तो जनरली वी कैन हैव रो टोटल व्हिच इज 400 इनटू कॉलम टोटल व्हिच इज 450 डिवाइडेड बाय द ग्रैंड टोटल व्हिच इज 1000। तो अगर आप निकालेंगे तो 200 के आसपास कुछ आएगा, कुछ अलग वैल्यू आएगी। 400 इनटू 450 डिवाइडेड बाय 1000, दिस यू वुड बी द फर्स्ट एक्सपेक्टेड वैल्यू। Similarly, for this you would be having the second expected value, and for third and fourth. So like that, you can have the expected values for all the cells, observed values for all the cells, and you can calculate the test statistics using the chi-square distribution here to check the association. Okay, और आपको एक calculated chi मिल जाएगा, calculated chi मिल जाएगा, and then you can refer it with, if you are using the software, you can refer it to the p value. If you are getting a very low probability value compared to your null, that means your data is not matching the null, you can reject the null hypothesis at a given level of significance. Whenever you are stating that the particular relationship is statistically significant, you should always state at what level you are talking about. Okay, many times I have seen in some journals, people are, what they are doing is that to make the things significant, they are increasing the error. They are taking alpha 10%. or in your sample size calculation, they are taking allowable error more than which is recommended to make the things more look significant. Okay, so you have to look at these things whenever you are stating that it is significant, at what level it is significant. So things might be significant at 5%, but it may not be significant at 1%. Okay. Now, so once we got the correlation and we have checked the causation using the testing of hypothesis, then we can have the mathematical model to predict the next outcome variable based on the input variables. Okay. So for that, we are using a regression analysis. Regression analysis is used when you want to predict a continuous dependent variable from a number of independent variables. Okay. Generally, if you remember your plus 2 or 10th, we have the line equation. We are having a line equation where we say that y is equal to mx plus c. अगर याद होगा हम जैसे कार्टेशियन प्लॉट में जब हम लोग बनाते थे तो इस तरह का रिलेशनशिप आता था. तो जनरली क्या होता है कि जब हमको ये पता चल गया कि एसोसिएशन बहुत स्ट्रांग है कोरिलेशन से, और फिर हम लोगों ने टेस्ट कर लिया टेस्टिंग ऑफ हाइपोथेसिस से कि ये सिग्निफिकेंट आ रहा है. ठीक है, गिवन दैट वी हैव पुट अ चेक ऑन द कंफाउंडिंग एंड इंटरैक्शन, ये हम लोगों ने कंट्रोल किया है. तब उसके बाद हमको चाहिए एक मैथमेटिकल मॉडल जिससे हम बताएं कि एक्स को 1 यूनिट अगर चेंज कर रहे हैं अपने इंडिपेंडेंट वेरिएबल को तो वाई कितना चेंज हो रहा है. तब हम रिग्रेशन मॉडल लगाएंगे. तो रिग्रेशन मॉडल एक इस तरीके का मॉडल है जो लाइन इक्वेशन जब हम लोग यूज करते थे वैसा है, y इज इक्वल टू एम एक्स प्लस सी. ठीक है, जहाँ पे y क्या होता था, हमारा आउटकम वेरिएबल होता था, और c जो है हमारा इंटरसेप्ट होता था, किस पॉइंट पे काट रहा है. इस तरह की चीज, एक लाइन का इक्वेशन आया. ठीक है, तो इसमें y इज इक्वल टू एम एक्स प्लस सी होता था. रिग्रेशन में हम जनरली इसको लिखते हैं y इज इक्वल टू अल्फा प्लस बीटा एक्स प्लस एप्सिलॉन. तो उसमें जो बीटा है वो एंगल होता है. इसका एंगल निकालेंगे, स्लोप, इस लाइन का जो स्लोप है दैट इज एंगल. तो हायर द स्लोप, अगर स्लोप बहुत ज्यादा है तो इसका क्या होगा, पर यूनिट चेंज अगर एक्स में किया तो बहुत ज्यादा पर यूनिट चेंज वाई में हो रहा है. और अगर एकदम पैरेलल आने लगा, इसका मतलब क्या हो रहा है कि एक्स में कुछ भी चेंज हो रहा है, वाई में चेंज नहीं हो रहा है. इसका मतलब रिलेशनशिप बहुत वीक टाइप का है. तो इस तरह के रिलेशनशिप को हम मेजर कर सकते हैं यूजिंग रिग्रेशन एनालिसिस. उससे कुछ अजम्पशंस हैं, जिसमें से एक अजम्पशन ये है कि जो आप सैंपल ले रहे हैं इट शुड बी कमिंग फ्रॉम द नॉर्मली डिस्ट्रीब्यूटेड पॉपुलेशन. ठीक है, इट्स अ वेरी broad term. I'm really sorry for writing the regression analysis in this way because it's a very broad term, regression analysis. I just want to give you some idea of what regression is all about. So regression is nothing but it's giving you a measure with the help of which you can measure that if you are changing an independent variable to 1 unit, what is the change in the outcome variable. It depends on your nature of the data. If it is continuous, we go with the linear regression. One predictor, simple linear regression. If you are having more than one predictor, we go with the multiple linear regression. If the outcome variable is not continuous one, if it is not continuous one, for example, it is disease, non-disease like that, then we go with the logistic regression. Okay. Okay, and sometimes what happens nowadays, what is happening is that the concept of regression analysis is getting modified very drastically. Why? Because there is not direct XY relationship. There are certain variables which are having certain impact. Okay. For example, if I have to have a relationship on you students, you people are having certain impact of the institute. You are having certain impact of the mentor who is teaching you. So generally we are having hierarchical model in that case. So X and Y are nested within some hierarchy. Okay. So nowadays we are having multi-level modeling also. Okay. So we will, whenever we will be doing some hands-on, it will be very clear on regression. Okay. Sometimes what happens is that you are measuring an outcome, and that outcome is associated with lot of variables. Okay. So there is a technique. If you are measuring the same concept and you are having lot of predictor variable for that one. So and then factor analysis is a technique to shortlist out of 10 options, what are the 2-3 options which are more prominent? Okay, so using factor analysis, you can classify out of a major chunk, you can classify few prominent variables, and then again you can run the regression model. Okay. For example, here we are having variables which are measuring, say, same domain, say socioeconomic status. It can a variable income, education, occupation, house values. All these variables are indicator of SES. But when applying factor analysis, we are finding that income is having more weightage than the rest. Then we can have education and occupation, like that. Okay. So the variables which are having least values of factor loading can be ignored. Okay. Now, this is another concept. Okay, I will be just giving you the idea what it is. Okay, why? Because it is very getting popular nowadays. So meta-analysis. What we meant by meta-analysis, why we should do a meta-analysis, when we can do a meta-analysis, and how we can do a meta-analysis. Okay. So why it is important? This is the first thing. Yeah. So we have seen in the study hierarchy, you will see that most weightage is given to the study designs which are based on meta-analysis. Yeah. Then we have systematic reviews in the integral part of that thing. Then we have RCT. Then we have cohort studies, case control studies, yeah. And at the least we have the exploratory studies. Okay. So in the study hierarchy, nowadays more weightage is given to meta-analysis. Why the weightage is given, we will come on that things. So because of this importance, it's getting popular day by day. What is meta-analysis? Meta-analysis is another word, in other words, is a process of combining a number of separate studies to produce one super study. Okay. For example, we might have 3 separate studies with a sample size of 40, 80, and 150. Then in combined, we can perform a meta-analysis and we can have a sample size of 270 to have a conclusive decision. Okay. Of course, it depends on certain things which have to be taken care of before performing a meta-analysis. Why we should do? If we follow assumptions of meta-analysis, is that this super study will provide a more reliable and precise overall result for the output variable in question than do any smaller individual studies. Okay, the very first line is very important. If we follow the assumptions of meta-analysis, okay, often we are not giving more importance to the assumptions. People are saying that we are getting very significant result on performing regression analysis, and if someone says that show us the regression diagnostic, show us the assumptions whether it is following or not, they are not showing that thing. Okay, so if they are showing the regression diagnostic, automatically it will be clear that the relationship is not causal in nature. There is confounding effect, there is interaction effect, lot of things are there which is misleading. So often it is said in statistics that every model is right. You have to choose the best one according to your objective. So whenever we are doing model building, it should always be supported by model diagnostic. आपने बता दिया कि ये रिलेशनशिप है, लेकिन आप ये भी बताइए जैसे आपने बताया है वो सिद्धांत वेरीफाई है, हो रहा है या नहीं हो रहा है. So model diagnostic is a very important tool which one has to perform. Okay. So अगर हमारा मेटा एनालिसिस का assumptions है वो satisfy कर रहे हैं, then our study is having more weightage compared to other type of study designs. When we can do a meta-analysis? We must have more than one study which has estimated something, and they must satisfy homogeneity criteria. The participant interventions or risk factors and settings in the studies carried out need to be sufficiently similar to us to say there is something in common for us to investigate. Okay. So what is happening basically? Meta-analysis is a study of studies. Okay. So what we have to take care of is that the raw material which you are incorporating before doing a meta-analysis, that means the systematic review which you are doing, it should be very scientific one. It should, in that study, you should measure the heterogeneity of your studies. If the study is of similar nature, If the studies are similar nature, then only they should be categorized in the same categories. If the studies are not similar nature, but for your sake you have ignored the heterogeneity and you have just done the meta-analysis, you would be giving a result which is a biased one. Okay, so meta-analysis is the second process. First process is the systematic review. Okay, so if you are following a sound systematic review system and then you are able to shortlist few articles, then you can do the meta-analysis. That means you can have summative measures based on 4-5 studies scientifically, and you can present it using some forest plot. Generally, we are having two types of model in meta-analysis. First one is a random effect model, and the second one is a your fixed effect model. So fixed effect model, what it is, if the studies are all of similar nature, if you can assume that they are of similar nature, and more or less they are telling the same type of story, same type of study area it is measuring, then you can have a fixed effect model. That means you are assuming that the parent population is same. The study is done in India on a particular type of a disease with a particular age group. If all of the studies are using same type of study, might happen that someone is using regression model, someone is using a correlation model. That is not important. We can always convert that thing. But the important thing is that the study area, the population, this should be of same nature. Okay. But if someone has established a relationship with, say, young adult population, but it is not holding for the old age population, it is not holding for the infants, it is not holding for this geographical region compared to other one, then you cannot have a fixed effect model. In that case, we go for a random effect model. तो generally हम क्या करते हैं, मेटा एनालिसिस में सारी स्टडीज को ले लेते हैं, हर स्टडी का जो टूल है, मतलब जो उसका मेजर आ रहा है, whether it is correlation, whether it is mean, whether it is odds ratio, whatever, we note down them and mathematically we try to convert them to a common scale. अगर correlation है तो उसको odds ratio में बनाएंगे, mean को भी odds ratio में बनाएंगे, and whatever the deviations which we are getting in each and every study, based on the sample size we are giving the weightage, then we try to have a summary measure of the variation, and उन सारी studies को मिला के हम एक summary measure बताएंगे, जिसको हम forest plot में आपने देखा होगा, last में एक diamond बनता है बड़ा सा, that is the summary measure, and the width of your forest plot, the confidence interval which you are getting, is giving you the idea about the precision of your study.